Welcome to the Explainer. Today we are going to tackle a topic that pops up all the time in competitive exams and honestly can seem a little tricky at first: boats and streams. But don't you worry, we are going to make this stuff crystal clear.
Have you ever wondered why these problems, of all things, show up so often in the quant section? I mean, really? Well, it's not just to give you a headache, I promise. The reason is actually pretty key to how these exams test your logic. Let's dive in.
It all boils down to one fundamental concept: relative speed. These questions are just a really clever way to test if you get how speeds can add up or, cancel each other out in a practical way. And by the end of this explainer, you're going to have this logic down cold.
Okay, first things first, let's get the fundamentals right. I want you to think of it like walking on one of those moving walkways at an airport. There are 4 key terms you absolutely need to know, so let's break them down.
So the stream, that's just the speed of the water itself. Think of it as this external force that's either going to help you out or work against you. It's the river's own speed. Now, still water, that's our baseline. It's the boat's true speed, its own power. Imagine it in a perfectly calm lake with no current at all. We need this number to figure out everything else.
And downstream? This is like walking with that moving walkway at the airport. The stream is literally pushing you along, so its speed gets added to your boat speed. Simple, right? You're going way faster than you would in still water.
And you guessed it, upstream is the exact opposite. It's like trying to walk against that same moving walkway. The stream is pushing back, it's fighting you, so its speed gets subtracted from your boat's speed. It really slows you down.
So, here's the bottom line, the main takeaway. Downstream, you add the speeds. Upstream, you subtract them. It's really just this simple push and pull dynamic. And believe it or not, that single idea is the engine behind every single one of these problems.
Okay, now for the best part. You do not need to memorize a dozen complicated equations for this. All you need are just four essential tools for your problem-solving toolkit.
Okay, take a good look at this. This is your toolkit. These 4 formulas are all you're going to need. The first 2, for downstream and upstream speed, well, that's just the concepts we talked about put into math. And the other 2? They're just clever little rearrangements that let you work backward. This right here, this is your entire arsenal.
All right, theory is great and all, but let's actually put these tools to work. We're going to take our brand new toolkit and solve a totally typical exam question. Let's see how it's done.
So here's our problem. We're given the combined speeds, right? The downstream and the upstream. Our job is to play detective and work backward to find the individual speeds, the speed of the boat on its own and the speed of the stream.
See, we just grabbed the right tools from our toolkit. To find the boat's speed, we use that formula. B equals half of downstream plus upstream. So that's half of 16 plus 10, which gives us 13 kilometers per hour. Easy. For the stream speed, it's half of downstream minus upstream. Half of 16 minus 10, that's 3 kilometers per hour. And that's it. Simple as that.
Okay, so solving direct questions is one thing, but what about those trickier problems? The ones that are designed to make you waste precious time during an exam. Let's look at a pro-level shortcut.
So sometimes you'll set up a problem perfectly. You'll use the basic time equals distance over speed formula, and then you end up with this complicated, messy, quadratic equation. In a timed exam, trying to solve that is a trap. But there's a much, much faster way.
And here it is. This is the secret weapon. Instead of doing all that painful algebra to solve for the variable, you work backwards. You actually use the multiple choice answers that they give you in the question.
Let's try this technique on a real placement level problem. The total trip, back and forth, takes 3 hours. The distance one way is 12 kilometers, and the stream speed is 3. We just need to find the boat speed, B.
So we set up our equation, right? The total time, 3 hours, equals the time going downstream plus the time coming back upstream. Now, instead of solving that messy equation for B, let's just test the options. Let's try option B, where B is 9. The downstream trip would be 12 divided by 9 plus 3, which is 1 hour. The upstream trip is 12 divided by 9 minus 3, which is 2 hours. And look at that. 1 plus 2 equals 3 hours. It's a perfect match. We found the answer in seconds without any of that complex algebra. Okay, so now you have the core concepts. You've got the essential formula toolkit, and you have a really powerful shortcut for those tricky questions. Let's just quickly summarize the key takeaways.
So here it is, your mastery checklist. First, get those 4 formulas locked into your brain. Always remember the basic logic: faster downstream, slower upstream. Read every question super carefully to see what it's actually asking for. Don't panic. And of course, when you see a complex setup, remember that awesome shortcut of just substituting from the options.
And that's it for this explainer on boats and streams. You are now officially equipped with the strategy and the tools to turn what might have been a confusing topic into an area where you can score with total confidence. Now go get 'em. Happy solving.